I just wanted to point out a couple of things. One is this is Polya's book off of my bookshelf, and I just wanted to point out that it's kind of cool that your book goes into Polya. I've been a fan of Polya. I have a copy of this. I've read it a couple times. I've lent it to people and asked them to read it, and I've sometimes received it back with damage. The book includes in it the same figure from your text, the sort of how to solve it poster. I kind of feel like this would be a good thing to have printed on a wall. Is lifted right out of Polya's book. This is the list out of his book. His book goes into much more depth than your textbook, and I feel like it would be very worth it. If anybody here is as much of a nerd as I am and wants to fill their bookshelf up with something useful, this is a good book. He has sort of a dictionary of heuristics, where he goes through and he defines all of these different ideas or aspects of problem solving, where he's really focused on generating the solutions to problems. So this is really good to get the patterns down to help you arrive at solutions. And he's got some examples, and if I flip a page here, at the end of his book he's got problems and hints. So examples of problems to solve in order to test your ability to apply this method, although you get plenty of those in any textbook. And for the ones that he gives you, he's got hints at what strategy to use, as well as solutions. So I can look at one real quickly, which is Bob has 44 coins and 10 pockets. Can he put a different number in each pocket? And you can kind of begin to play around, maybe pause the video and try to answer that question yourself. And now I'm going to begin introducing the process that I went through on a previous page, and I'm going to try to more elegantly present it now. But the process I went through is I immediately tried to substitute, he's got n different pockets and m different coins, and what is the condition on m? Because if he has enough coins, I felt like you could always do it, but I wanted to know what is the condition on n. Then I thought about the pockets. So if he's got pockets, let me kind of draw a pocket like this. So maybe this is P1 and P2. So he's got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 different pockets. And it says he's got a different number in each pocket. So it's the same solution if you were to swap any two pockets. So no matter how you permute it, you could always arrange it so that P1 is less than P2, not equal to, because they must be different, which would be less than P3, and that would be, of course, in the end, just like that. So these pockets could be sorted in order, and then you could always swap them back to get any other possible solution. So instead of solving this original problem, I could instead try to solve this problem. So assuming that each pocket has fewer coins than the pocket that follows it, is it possible to use 44 coins? And for that, my question is, what's the condition on m? So I'm looking for a limit. So then I asked myself, what is the minimum value of m? What's the minimum I can use? And since the total number of coins is the sum of what's in each pocket, I want to put the fewest number of coins in each pocket. So if I put 0 coins, and is 0 okay? I mean, that's kind of a thing that you might question, but there's nothing that rules it out. So I'm going to put 0 in the first pocket. I'm looking for the minimum, and I feel like we can get that. I have to have a different number in pocket 2. It's got to be bigger. So I can see that you end up counting 0, 1, is 3 the minimum? No, 2 is the minimum I can put there. 3 is the minimum I can put there. 4, so I'm counting up. Each pocket cannot be fewer than 1 more than the previous pocket. So 5, 6, 7, if only I could count, 8 and 9. And if I add these together, so I'm just going to keep track of the total up to a point. So up to here, my total number of coins is 0. Up to here, my total number is 1. Up to here, it's 1 plus 2, which is 3. Up to here, it would be 3 plus 3, so I can just add to the previous total. 3 plus 3 is 6. 6 plus 4 is 10. It's the end of a day today, and I am having a hard time adding numbers. So, for instance, that should have been an 8 and a 36. 6 plus 9 is 15, so 45. So the total of those coins is 45. And I can see that 45 is bigger than 44. So the minimum value that I could put in 10 pockets is bigger than 44, which means that I can't do 44. So the answer to that question is no. And looking back, I can get more general. So I can see here that the requirement is that the sum from 0 up to, if 10 is n minus 1, I have to make sure that m, my number of coins, must be greater than or equal to, this is the sum from maybe I equals 0 to n minus 1 of I, which is, if you've taken the right math class, you'll know that's an arithmetic series. These things pop up all the time in computing, and it's useful to memorize that that is equal to n times n minus 1 over 2 in this case. So if you plug in for n equals 10, you get 10 times 10 minus 1 over 2 equals 90 over 2, which is equal to 45. So our condition is, if we were to solve the problem, you have m coins and n pockets, can you do it? And the answer is if and only if m is greater than or equal to n times n minus 1 over 2. So we have not just solved the original problem, we're pretty easily able to solve a more general problem, and we kind of have a new theorem, a new fact, a new piece of knowledge that we can apply to future problems of the same sort. So with that, I'll wrap it up. There are a bunch of other interesting problems in the book, and what's cool is in that book, we just did problem number 3, 10 pockets and 44 coins. I didn't look at the hint, but I could have. He's got hints here. Let's see. Hints. So for problem number 3, the hint is, could you restate the problem? What's the minimum number of dollars? So we stumbled across that idea as we did it. And if I keep going, I think he'll have a solution to that problem as well. And gosh, I hope I got it right. He can't make it because he would need 45 and he only has 44. So the same logic too. The least possible numbers is 0, the next is 1, the next is 2. His thought process didn't involve sorting the pockets, but it's similar ideas there. So with that, I'm going to wrap it up, and I'm going to continue with Chapter 7 about algorithms.